The annual salaries of registered nurses are normally distributed with a mean 28,000 and a standard deviation of 1,700. It's probably a randomly selected nurse will earn between 22,500 and 25,000. 22,500 and 25,000.
Excuse me, Mr. Lewis. Can I have one of those?
Of course.
14. 13 is up there.
So what's the first one? Normally distributed. Right? What's the mean?
28,000.
28,000. What's the z-score for that?
0.
0. Here's 10 minus 10. We're interested in what? Probability are between what and what?
22,500 and 25,000.
What is it again?
22,500
And what?
25,000.
And 25,000. Right here, right? We're interested in that probability right there, right? So we have to find, we have to find a z-score, right? So we need a z-score for 22,500. That is 22,500 minus 28,000 divided by the standard deviation. What's the standard deviation?
1,700.
1,700. So this would be 22,500 minus 28, 5,500 divided by 1,700, right? And what would that be? Negative 55 divided by 17 is negative 3 something.
Negative 3.24.
3.24. This is a z-score of negative 3.24, right? Then we need a z-score for 25,000. This would be 25,000 minus 28,000 divided by 1,700. This will be negative 3,000 divided by 1,700. And what is negative 3,000 divided by 1,700?
Negative 1.76.
Negative 1.76. The question then is, what is that area? How do I find that? That would be normal CDF between any two z-scores, negative 3.24 and negative 1.76. And what is that?
0.038.
0.038. The answer should be 0.038. Everyone okay with that?
What's the probability?
Probability is 3.8%. The nurse will earn between 22,500 and 25,000. Given the average is 28,000, with a standard deviation of 1,700. Okay. Now, if you're a smart little whip, do it this way. Normal CDF between any two scores. 22,500, comma, shouldn't do that, 22,500, comma, 25,000, comma, the mean, 28,000, comma, the standard deviation, 1,700. When you do that, you should get back the same value. Did you? You like the hard one.
That could take a lot more. Free up some brain cells.
Yep.
Go back 0.038. So it'll compute the z-scores for you automatically, but you got to be careful to put in a score small enough and big enough if you don't have simple standard deviations. So it's got to be clear. Never fails to use 10 and negative 10 if you're doing z-scores. If you don't do z-scores, negative 10 and 10 won't work as you're lowering up or down. You got to get values big enough. Okay? We'll finish this problem and we'll call the night. Suppose a registered nurse at one hospital earns a salary that ranks in the 10th percentile. what does this mean? What is this nurse's salary? So she ranks in the 10th percentile. Where is that nurse's salary? Right there, right? That's where the nurse's salary is. What's our average salary? 28,000. What's the Z-score? At a negative 10. Never changes. We need to find the salary right here. How do we find the Z-score for an area of 10% to the left?
Inverse norm.
Find it by inverted norm, 0.10. And that value is what?
Negative 1.28.
Negative 1.28. So then to find that value, what does that mean? Now it's simple. 1.28 means 1.28 standard deviations below the mean. So in this case, that would be 28,000 minus 1.28 standard deviations. 28,000 minus 1.28 times 1,700. And what is 1.28 times 1,700?
You want the whole answer?
Now just 1.28 times 1,700.
2176.
What is it?
2176.
2176. 28,000. That puts me at 25,830. 24. All right?
Yep.
25,824 is the nurse's salary to be in the 10th percentile. So 10% of nurses earn less. 25,824. 90% earn more than 25,824. Last one for the night. C. Yeah. Say again. Invert norm 0.10. How do you get that? Okay, you go into this DISTR. It's the second DARS key above the VARS. Third one down. Because it said the nurse is in the 10th percentile. That means that nurse, 10% earn less, 90% earn more. That's how I do it. Okay? C, last one. Now I've gone out and I have sampled 35 nurses. What's the probability that the mean annual salary is more than 28.5? Okay? What theorem is necessary in order to perform this calculation? How many theorems did we study?
One.
One. What is it?
Chevy
Central limit theorem. Central limit theorem.
Oh, never mind.
Okay.
What was that again?
Central. That was good. Central limit theorem. Central limit theorem. If you ever ask on an exam what theorem behind statistics, always guess central limit theorem. You don't know. Always guess. It's kind of like if you ever teach Bible school, you give an exam. Always say God is good, or I know Jesus, or I read the Bible, anything like that, you get full credit, right? Same thing. Central limit theorem.